Yep. Let me do one thing before I do the shading. Let's place elements in a Venn diagram. It's not hard, but just want to make sure point it out. Yeah, let's go back to the universal set is 1 through 10. A is the even 2, 4, 6, 8, and 10. And B is 1, 4, 5, 6, and 9. I want to place those elements in the appropriate place of a Venn diagram. Well, here's the deal. Each element, there's only one place it goes. For example, element 1 goes in one place, and what place would that be? Well, notice that 1 is in A. Well, let me first mention, universal set is 1 through 10. If I put the element somewhere, if I put 1 through 10 somewhere in this diagram in the rectangle, it's in the universal set. The universal set is the whole rectangle. So anyway, 1, where would I want to put it? Well, it goes out here, doesn't it? Right? Because it's in B, so as long as I put it in the B circle, I'm okay. But I wouldn't want to put it here, because if I put it here, what happens? It'd be in the A circle. So yeah, it's got to be in that moon-shaped part of the B. What about 2? Same thing, but in the moon-shaped part of A, right? 2 goes here. What about 3? Well, 3 is not in A, it's not in B, so it's got to go outside of those 2 circles. So somewhere, it doesn't matter where, put it wherever you want, but somewhere outside the circles. 4 goes where? It goes in the middle because it's in both of them. And that's where we can have both sets. 5 is only in B, so it'd go out here with the 1. 6 is in both, so it'd go in the middle. 7's not in both, either one of them, so it goes on the outside. 8's in A. 9's in B only, and 10's in A only, so I get that. Agree with that? Okay, so it's not a big, hard deal, but I just want to point that out. All right, so now let's go to shading. A little more shading. All right. The thing is, we talked about shading a little bit. We want to think about some more complicated things on the shading, and actually throw in a set C in our shading as well. But all right, so let's take number 1. Shade appropriately the Venn diagram A, complement, intersection B. A little more complicated because we got the complement and the intersection, and there's different ways of doing it. Here's my recommendation. As we get more and more complicated, this helps out a little bit, I think. Okay, let's go back to the numbering thing, because I've got 4 parts here: 1 and 2 and 3 and 4. That's usually the way I number it. You don't have to number it that way, but it's usually the way I number it. Well, what we can do there is say, well, if I number it off, then I can put some numbers to these sets, and then I can intersect those numbers. For example, A complement here is what's not in A, so that's 1 and 4, isn't it? Of course, B is the B circle, so that's 3 and 4. So if I intersect those, what is it? intersection means what's in common. What do those have in common? 4, right? The common ground of these two is 4. That's what I shade for this set here. So for me to shade A complement intersection B, I would shade only region number 4, which is this moon-shaped part of B. See that? It just gives you a way to put something down so that you can, I mean, there's other ways of doing it. You can think about, well, this sets this, where do they overlap? I like this way. Puts numbers to it. Okay? Okay, so number 2, let's shade A complement union B complement. So we got this Venn diagram. I want to shade A complement unioned with B complement. Well, if we go with my numbering system there, 1, 2, 3, and 4, again, A complement is which ones? Well, A is 2 and 3, so A complement would be 1 and 4. I want to union that with B complement, cover up B. B complement is what? 1 and 2. So putting those numbers to those sets, now I can just union those. So I want to union 1, 4 with 1, 2. What does union mean? Put them both together. Put everything in one with everything in the other. So I go 1 and 4, union that with 1 and 2. What is that? 1, 2, and 4, isn't it? So I shade these. I'm going to shade all 1 and 2, everything but 3. So I'm going to shade 1, which is the outside part. I'm going to shade 2, and I'm going to shade 4. Leaving everything shaded but 3. With me on that? Okay. Number 3 to do right here. Shade A intersection B complement. Parentheses around A intersection B. The complement on the outside of the parentheses. Okay, well, first part's easy here. Do inside parentheses first. A intersection B. What's A intersection? A is 2 and 3. Intersect that with B, which is 3 and 4. Then I complement that. So 2 and 3 intersection. That's 3, isn't it? So the parentheses part is 3. However, there's a complement on the outside. What does a complement mean? Well, it's not in there. So the inside's 3, but I want to complement that. So what's the complement of that? 1, 2, and 4, isn't it? That's what I shade for this set. 1, outside part. 2, and 4. Everything but 3 again. Okay? Now, I do that one because it's another example, but I also do that to kind of show you a usefulness of this shading, because do you notice here, this set wound up being exactly the same as that set, didn't it? On the Venn diagram, I shaded the exact same thing. Well, what that means is these two sets are the same thing. If they cover the same ground, cover the same shading, they're equivalent sets. So this set is equivalent to this, and vice versa. So that's one thing as far as Venn diagrams you can do. Is you can prove equivalent sets. You wouldn't maybe think that that was true, but it is true based on our Venn diagrams. Okay? All right, let me finish up here. Let's talk about 3 set Venn diagrams. And I'll be done. Yeah, so I've got an A. Got a B. But I've got a third set C. Well, C, couldn't it overlap A? Couldn't C overlap B? Yeah, I'm going to have to draw somehow C in here where it overlaps the others, and usually this is the way we do it. Yeah, C is going to overlap possibly the other 2 sets. Okay? All right. Okay. So let's shade a couple of these. A, parentheses, A, intersection, B complement, union, C. Well, if we use my numbering system here, notice we got a few more parts. If I number these off, if I start again on the outside as 1, then I go here 2, 3, this one, 4 here, 5 here, 6 here, 7. I'm getting 8 different parts. You don't have to number them exactly that same way, but this is one way we could number them. I've got 8 parts, 8 regions. Well, to shade this set then, let's do that. We'll do parentheses first. So I take A. Now, notice here A has many multiple parts. A is everything in set A. So that's 2, 3, 5, and 6 is A. I'm going to intersect that with B complement, and again, B complement, cover up B. What's not in B, that's B complement. What's B? Complement. 1, 2, 5, and 8 by my numbering. See that? Cover up B. B complement is 1, 2, 5, and 8. And then I'll take care of union C in just a second. So I'm going to intersect 2, 3, 5, and 6 with 1, 2, 5, and 8. So that's 2 and 5, isn't it? The common intersection is common. 2 and 5. So this intersection is 2 and 5, but I'm going to union that with C, which C is 5, 6, 7, and 8. So what do I get? Union means put everything of those two together. So I put everything here, combined with everything here, what do I get? 2, 5, 6, 7, 8. That's my shading by my number system. I'm going to shade 2. I'm going to shade 5. I'm going to shade 6, 7, and 8. So A intersection B complement, union C. That's it. One more? Can you do one more? Let's do one more. All right, so let's shade A intersection B union C complement on the outside. B union C parentheses complement on the outside. A, B, and C. Parentheses first. So 1, 2, 3, 4, 5, 6, 7, 8, if you want to number them that way. Parentheses first. So do B union C first. B is 3, 4, 6, and 7. Union C, which is 5, 6, 7, and 8. I want to complement that, and A intersect that. What's inside the parentheses here? You tell me. Union? What is it? Put both of them together, right? 3, 4, 5, 6, 7, and 8 would be the union of those two. But there's that complement in this A intersection with that. What's next? The complement? What would be the complement of that? What's not in there? Well, 3, 4, 5, 6, 7, and 8's in there. 1 and 2 is not. So this complemented is 1 and 2. With me? I want to intersect that with A, which A is 2, 3, 5, and 6. So if I intersection those two, what do I get? The intersection is what's in common. So the intersection is just 2, isn't it? Yeah, this one doesn't have a 1, so 1's not in it. They both have 2. The only thing there in common is 2. That's all I say. Two. Out of all that, I'm only going to say 2. Is this okay? All right.